Hi there, so I'm going to go over some pro tips on using Tinkercad to make a 3D printed model. You may want to do a 3D printed model for an enclosure for your invention. So let's do a few background things first. All your measurements should be in millimeters. It'll give you the most precise measurements for whatever it is that you're doing. So find a good ruler and make sure you can find the millimeter side. The numbers on the metric side of your ruler are in centimeters, so just add a 0 to the end of each one, and that's how many millimeters it is, 10, 20, 30, and so on. It doesn't matter what color you make things in Tinkercad. You do want to make sure things are only one color in Tinkercad because you want it to be one solid object. Our 3D printers cannot print multicolored objects, and you will choose the filament when you 3D print. So if you make an item green in Tinkercad, you can just change your mind when you 3D print it and make it red or gold or whatever. A really important pro tip with Tinkercad is to avoid big overhangs and avoid tiny fragile parts. The tiny fragile parts are not going to print well, they'll snap off really easily. And this is what I mean by a big overhang. Let's say you're printing a box like this one. If you printed this box like this, the 3D printer would be able to print the bottom just fine, and it would print the sides just fine, but when it got to the top it would start having trouble. As it extruded the plastic filament along this long edge, it would start dripping the filament down through this air space onto the bottom layer, and you'd end up with a big mess. The way the 3D printer can compensate for this is by printing a really fine mesh inside the box to support the roof. But as it prints that fine mesh, now you have this mesh that you have to cut out of your box later, and it's going to make it so the inside isn't as smooth and pretty, and it's a lot of trouble. So I recommend you just avoid big overhangs like this one. If you have a small one, it's not going to be a huge deal, but a big one like this is going to create a lot of mesh. So print the box like this. This one will have no supporting mesh to deal with. It doesn't have any surfaces that are overhanging, and this will 3D print with no problem. You won't always be able to avoid all overhangs, but try to minimize them as much as possible and really keep an eye out for where it's going to print mesh and where you'll have to cut it out later. If it has an overhang greater than 45 degrees in any area, it will print mesh underneath that overhang. So next we're going to start talking about how to make an enclosure for something like a microbit. Now if you must make a closed box, then it's recommended that, like let's say you want to make a house or a garage, it's recommended you print it in two parts. So if this were going to be a house with a roof, take the roof off, put the roof to the side, print the house and the roof separately, and then you can super glue them together later. Okay? So in order to start on our microbit container, let's begin by signing on to Tinkercad. Open up a web browser tab and go to tinkercad.com and choose Sign In, and you're going to sign in with your Google account. Okay? So once you've signed in with your Google account, you'll be taken to the main page, and you want to make sure you're on 3D Designs and choose Create New Design. Okay, we see our work surface right here. You may get taken to a tutorial the first time you do this. You can skip the tutorial. So let's go back to our document. When I measured this microbit to see what its dimensions were, I measured it in millimeters and found out it's 52 millimeters wide, 42 millimeters high, and then it's 13 millimeters deep. And so that 13 also includes the battery connector and the button on the front. So what I recommend you do is take your width and your height and add 6 millimeters to each. So what that does is it gives you 1 millimeter on each side just for better fit, and then it gives you 2 additional millimeters on each side for the thickness of the box itself. So 1 millimeter for fit, 2 millimeters for the thickness of the box, and then if it's going to be an open box on the top, like this one's going to be, then you just need 2 additional millimeters for fit, and then 2 millimeters for the box itself. I'm assuming you don't want to put a lid on this box because that would be silly to print a completely closed box. You couldn't put anything inside it. So also notice these measurements are for the microbit alone, not for the microbit plus battery pack. So if you want to include the battery pack, you'll need to take measurements with the battery pack nesting it against the side. So let's use those measurements to just make a box for a microbit. So here's how you do it. Over in Tinkercad, we've made a new design, and we'll start by getting a box. So I'll drag it out there, and then I'm going to make the width and the height be my dimensions of the microbit plus 6. So if I click on this square in the corner, you see how measurements pop up? By default, those are in millimeters. Click on the box and then they snap in place, and you can actually click on the numbers and enter different numbers. You can also drag this box and try to get close that way, but you'll often overshoot or undershoot, so just type the measurements you want. So it was 52 wide plus 6. 52 plus 6 is 58. It was 42 high plus 6. 42 plus 6 is 48. And then it was 13 millimeters deep plus 4 because it's an open box. So 13 plus 4. Again, what I'm going to do is click on this square in the center, and that gives me the depth of the box. And then I can click on the number and make this be, let's see, 13 plus 4, 17 millimeters deep. So if I grab my right mouse button and I rotate it around and pan it, I can see these are the dimensions of my outer box. So I'm going to go back to my pro tips. So I've added 6 millimeters to the width and height, and then 4 millimeters to the depth to make the outer box. I've made that out of solid material. Now I'm going to add only 2 millimeters to each measurement, and that'll be the size of my inner box. And we're going to make this out of whole material. So we'll go back to Tinkercad and notice there's a box that's solid. There's also a box that's a hole. I can also grab another solid box, but then click the hole button and it will turn it into whole material, so it's hollow. And we're going to make this inner box be the dimensions plus 2 on all sides. So again, I'll click this lower corner and I'll see the numbers for the dimensions. This dimension will be 52 plus 2, so 54. This one will be 42 plus 2, so 44. And then the depth, if I click on the center box, I can grab the depth, and I can make this be 13 plus 2, so 15. You'll notice it is also possible to grab the sides and this cone, and it'll also move the box around and resize it a little bit. If you grab this cone on top, it lifts it off the work surface, so you want to make sure it's sitting flat on the work surface. Make sure that that height off the ground is 0. Okay, next step. So we're going to take the whole material, nest it inside the outer box, and use the alignment tool to snap it into place. This is what that looks like. The inner box gets nested inside the outer box, so I can't really see it right now. And I'm going to use my right mouse to pan a little bit. I'm going to use my select tool, so just use the left mouse button and drag a box around both of those. And then if I look up in the upper right, there's this tool that looks like a bar graph, and this is the alignment tool. Click on that and you'll see some lollipops show up around the sides of your box. I'm going to align my two boxes with the center lollipop here and the center lollipop here, but then I'm going to use the top lollipop so that the open part of the box is at the top. So that took the inner whole material and aligned it along the center and then at the top, so that open face is flush with the top. It's now perfectly aligned. Everything looks really good. So let's take my select tool and drag around both boxes again. And if I go on the upper right again, this shape that looks like a square and a circle together is your group tool. Click group, and it joins the whole material with the solid material, and now we've made a hollow box. And this hollow box would perfectly hold a microbit just by itself. This box looks nice. There's no overhangs. There's nothing preventing me from 3D printing this. So I could 3D print this. In order to 3D print, I would first change the name. Okay, and then I click Export. And when I export it for 3D print, I'm going to choose .stl to make it an STL file. Now, just as one extra pro tip, let's say I wanted to make a box that had a clear lid so I could see what was inside it. To make a clear lid for this box, I would want to laser cut a lid for it out of clear acrylic. So a cool tip with Tinkercad is that it's really easy to laser cut a clear lid for a box like this. So you want to make sure the bottom of your box is right at 0 on this work plane here. And if you're not sure, just grab the cone and make sure that the number shows 0 as you try to drag it up and down. Okay? Make sure it rests right on the work plane. And then when it does, you can say export, only this time you're going to do SVG for laser cutting. And STL is the 3D print file to 3D print it. And then the SVG is the laser cutting file to laser cut a lid out of clear acrylic. And then you could put a lid that perfectly fits on there, and it would be a perfectly designed microbit box. If you wish to check to see if a microbit would really fit in there, one fun tip is that if we pull down this menu, you can go down to Circuits and choose Components. And there actually is a microbit in the components if you scroll down a little bit. So you can pick up a microbit and you can drag it in there and you can see how it would fit inside your box. So it's just kind of a fun tool to be able to explore and see how certain components fit in there. You can also grab things like battery packs, and like here's a AAA battery pack, so you could grab one of those and put it on your project and make a box that includes that too. So just some fun things that you can do with Tinkercad that go a little bit beyond what you might be used to. I hope this tutorial will help you, and it helps you to design the perfect 3D enclosure for what it is that you want to do. And good luck with your project.